Hi everyone, my name is Bishan Panesar. I am Head of Key Stage 5 Maths, Deputy Head of Maths Department at Woolwich Poly. Welcome to this online session where I will show you how we use visualizers and how I use a digital pen to deliver online live lessons. On the top right, I have a do now task for you to attempt. Which colour from this image here has the most spots? Please use your gut instincts first, write down the answer, and I will come back to this question later on in the session. When we first started delivering online lessons, you can see that I'm using my phone as a visualizer. Mr. McGuinness, who is an assistant head teacher at Woolwich Poly and a lead Key Stage 5 maths teacher, is using his visualizer to deliver a lesson, but the lighting was so strong that we decided to open up an umbrella to ensure that the image was clear for students to see. For me, these images represent the trial and improvement journey that we were on. As a school, we were offered training on Microsoft Teams, and you can access the resources from this link here. As a Key Stage 5 Maths team, we offered home learning scheme of works to Year 12 and Year 13 students. This is what we shared with students in March, and I want to play a clip of me teaching at home for you to watch.
Trying to understand what these inequalities actually mean. Remember, it's a discrete random variable. That means you can't have values in between 5 and 6. It can either be 5, 6, 7, 8, 9, 10, 11. Now, from here, your calculators give you values where x is less than or equal to something. So let's work from the top end first. X is less than or equal to 11. Okay?
We use the poll function in Microsoft Teams to interact with students and decide on which questions to cover with them. This is what we shared with the Year 13 students from March onwards. And here you can see what students were able to view from our visualizer as I was going through this question, and I used GeoGebra to represent graphically what the question is asking students to do. Coming on to September, we offered sessions every Wednesday and Thursday after school to support student learning from 5 to 5:30 p.m. This was for all Key Stage 5 Maths students, and the feedback from those sessions is available for you to see here. Based on that feedback, we now offer sessions to Year 12 students every Wednesday after school and Year 13 sessions every Thursday after school. From one of those sessions, I've actually taken a clip to show you how I use my digital pen to provide live feedback to students as they are learning online. So let me play that clip for you.
There's no such thing as a normal dy by this is not correct, okay? Because what you mean is that dy by dx is equal to 2, okay? So that's saying that the gradient is equal to 2. The normal you should be writing as m1 or mn. Mn is equal to minus a half, because this doesn't make sense. You see what I mean? I've never ever seen or written normal dy by dx, making something up there. So the way I would do it is dy by dx is equal to 2. Therefore, the gradient of the tangent is equal to 2. The gradient of the normal is equal to minus half. You can either use, and then once you got this, y equals 0, that's fine. You just pluck that out thin air, but I'm assuming that's correct. And also, because it's a show that question, you can't just do these things because they want to see every step. So yeah, it's good. You've done everything, but just the presentation has to improve a little bit so that you don't lose any marks, because this is a show that question. And just to show you, have a look at the mark scheme. This one, you have to show the steps. Otherwise, you're going to have problems. So please make sure the 16 cannot just have been made up.
For this question, I would also share with students that I can get the answer in my calculator for the integral. So it's important to actually narrate your thinking to the examiner to get all the marks. And in terms of narrating your thinking and structuring your response, let's come back to our do now question. So for this question, I want to now break down the problem. Can we work systematically when answering this problem? Don't just add up the spots. Can we break down this problem a little bit? Can you see any features of this problem for when you want to add up the 1s, the 2s and the 3s? What shapes can you see? Can you use the squares to make this problem a little easier? How might you calculate how many 1s there are? So a lot of thinking is required for any maths question, and we want to try and improve the thinking skills for students. Let me use my digital pen. So here I've got all the different colors that I use. I'm going to select a red color for now and try and break this problem down. So I'm going to create a strip here. Let's create another strip going down here. The strip going across, and we have a strip. So I've just broken this problem down a little bit, and I've got a neater version on my next slide. Now let's write down some calculations. So I've got four strips, and in those four strips, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 squares, and in each of those squares I've got one spot. So that's going to give me 40 spots from the white squares. Now let's see if I can break this problem down into strips as well. I've got a strip here and a strip here for the black squares, and you can see I can just follow this through. Strip going across and a strip going up here. So, and again, for the black squares, we've got four strips, and in each of those strips I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 squares, and each of the squares have 2 spots in them. So let's work this out. 8 is 16, 32. 32 times 2 is 64. So there's 64 spots altogether in the black squares. Now let's think about the green one, the green squares. So can I actually conjecture? Is there a pattern here? I've started off with a small case. I'm trying to specialize, and I'm going to try and see if there's a pattern. So would I have 4 strips? Potentially. And what's the pattern here? 10, 8, 6. We're going down in 2s, and then we should probably be going up in 1s here. 4 times 6 times 3. So if that's what I'm thinking is for green, for my blue and for yellow and red squares, can I follow that pattern through, and would it work? So let me just use a different color pen here. Let's use a green pen. So I would have 4 strips, 4. So that's going to remain the same. This is going to go down by 2. So that's 6 and 4 go up by 1. And here we're going to have 4 again. 4 go down by 2, go up by 1. And then I've got 4. If I go down here by 2, I'll get 0 and go up by 1, 6. So there's a problem in the last one. And if I actually look at it visually, I've only got 1 square. So I wouldn't really get 4 strips. That's not going to be correct. That's not going to be correct. And there are 6 spots. So I've only got 1. That would be 1 times 6. So you can see that the pattern is not holding for the reds. And these are the kinds of skills that we want students to really develop when I'm answering these types of questions. So let's now go and work out what these values are. 4 times 6 times 3. Do I have the 4 strips here? I believe I do. Let me just double check. 1, 2, 3, 4. And 4 times 6 times 3 is 72. 4 times 4 times 4, I would have the 4 strips here. 1, 2, 3, 4, and I've got 4 squares in each strip and 4 spots in each square. So 4 times 4 times 4 is 64. My time has just gone. Let me just dismiss that. And the yellow one, I've got 4, so that's 2. That's correct. 4 strips and 2 squares with 5 spots, and that's going to give me an answer of 40. And the final one, well, you can just see it's just 6 spots. So here's all of the calculations that I've done, and the answer is this one here. So if you chose green, well done. That is indeed the correct answer. I can also represent this graphically. So if I actually wanted to represent this graphically, for the first row, I've got 1 spot in each square, and altogether I've got 40 spots. Second row, I've got 2 spots in each square, and altogether I've got 64. If I carry on going and plot my coordinates for each color, there's a very nice shape here which you can share with students. And we're just trying to use different skills to answer the question. So this is what I try and do for all maths questions: model and really make students think about what the question is asking them to do and build problem solving skills. Thank you so much for joining this session. Hopefully you've gained something from it. I've shared a couple of links in my last slide.